Good morning to all of you. Welcome to the class of fluid mechanics and hydraulic machines. In the previous session, we discussed about the fluid classification. In this session, we will discuss about the fluid properties. So let's go to the fluid properties. Here fluids, that means we are dealing with the liquid. Fluid properties, various kind of fluid properties are there. Few of them is listed here, like the mass density, also called the density, weight density, that is called the specific weight, specific volume, specific gravity, surface tension, capillarity, compressibility, viscosity. So these are the few listed properties of the fluid. We will discuss one by one. So first one is we are going to discuss the first one, that is this is mass density, also called the density. What is mass density? How we can define the mass density? That is that simply it is called the density or the mass density, that is the mass upon volume. Mass per unit volume is called the density. Simply mass per unit volume is called density. That is if whatever the mass of the liquid, if that divided by its volume, we will get the density of the fluid. What is the unit for the density? Mass is having the unit of kg, volume is having the unit of meter cube. So kg per meter cube, this is the unit for the density. What is the dimension for the density? This is for the mass m, for the volume it is LQ. So that is ml minus 3, that is the dimension for the density. So mass per unit volume is called the density or mass density. Next we are going to discuss about the weight density. What is weight density? Weight density, that means this is also called the specific weight. Weight density, that means weight upon volume. Weight upon volume is the weight density, that is the weight per unit volume. In the previous case it is the mass per unit volume, in this case it is the weight per unit volume. Weight can be written as mass into g, that is the volume is there. So this mass upon volume, this can be written as mass density. Mass density or density, simply it is represented by the term rho, that is the density. So this rho into g, you will get the here weight density or specific weight. So this is the relationship between the density and specific weight. Also you can say what is the relationship between the density and specific weight. Then you can write, if the specific weight is defined as the gamma w, just this is the symbol I am representing here for the specific weight. So specific weight is, that is equal to density into g. G is the acceleration due to gravity, that's the standard value, that is the SI unit value. For g it is the 9.81 meter per second square. So that is the first one is the density or mass density, and second one it is the specific weight or weight density. So next one we are moving to the specific volume. A specific volume, how we can define the specific volume? A specific volume, that is the volume per unit, how much there is the mass in the per unit volume, that is the specific volume. Thus the reciprocal of the density, we can say. A specific volume is the how much volume is there per unit mass. That is simply it is the, if you say this is 1 upon rho, that is the, if you define the density, that is the mass upon, density is what? Mass upon volume. So volume upon mass, that is the volume per unit mass, it will call the specific volume. Simple. Then you are moving to the next one, specific gravity. A specific gravity, what is the specific gravity? This is a specific gravity. This one is the specific weight. See, this is a specific weight. This is a specific gravity. How can you define the specific gravity? A specific gravity is the dimensionless. You have to do the work as a assignment, like what is the unit for all these properties and what is the dimensions. A specific gravity. A specific gravity is dimensionless, that can be defined as the ratio of two density. It is the ratio of two density. Specific gravity, this is the ratio of two density. Ratio of two density, that means what? Density of the fluid, density of fluid for which you are going to find out the specific gravity, and divided by the density of the standard fluid. Density of the standard fluid. Or sometimes it is also called the density of the reference fluid. Reference fluid or a standard fluid is taken as the water in case of the liquid and air in case of the gases. For water, standard density is taken as the rho W, the density of water, that is taken as the 1000 kg per meter cube. 1000 kg per meter cube. So if you know the specific gravity represented by here SP, if you know a specific gravity of the fluid, then simply multiply it with the density of the water in case of the liquid, fluid is liquid, then you will get the density of that fluid. Suppose oil is there. If you don't know the density of the oil, but if you know the density of, if you know the specific gravity of that oil, then suppose a specific gravity is 0.6. Suppose specific gravity is 0.6. Let me explain here again. Erase it. Suppose the specific gravity is 0.6. A specific gravity for oil. For oil it is 0.6. Specific for oil it is 0.6. Then you know specific gravity, what is that? Is equal to the, that is equal to ratio of the two density on the density of the oil. Here the density of oil, as you are going to find out the specific gravity for the you have to find out the density for the oil, that oil. So specific gravity is given 0.6 for that oil. Now how to get the density of that fluid, that is oil? So density of oil divided by the density of water. A specific gravity is given 0.6, so 0.6 equal to density of oil divided by the density of water, 1000. So you are getting here the density of the oil, density of oil, that is 0.6 into 1000, that is 600 kg per meter cube. That is the specific gravity. This becomes the 600 kg per meter cube, the density of the oil. Now we can see here density, that is the mass upon volume. How much mass is there per unit volume? If you having the, one is the oil, one is the water. Oil is having 600 kg per meter cube density, and it is having the water is having 1000 kg per meter cube. That is in per meter cube, that is the unit, in unit volume oil is 600 kg, while in the same unit volume water is 1000 kg, right? So in this way you can analyze in a unit volume how much mass is there. if more mass is there or less mass is there, that will define by the, that can define the density. So next, coming to the surface tension. Let me erase this one. Next, we are coming to the surface tension. How we can define the surface tension? Let's see here. Surface tension, that means the, define it here, surface tension. Surface tension is the property of the fluid. Because of that, fluid is tendency, that is the tendency of the fluid surface to shrink into the minimum surface area possible. That means the fluid surface tends to shrink into the minimum surface area whatever possible. This is because of the property of the surface tension. At mean reflects surface tension, that is tension on the surface, that is there is the some tension, some stress on the surface. We have seen the, when the rainfall happens, then drops having the circular shape or nearly circular shape. So why it comes to the circular shape? Circular shape is having the minimum possible area, it is having the minimum area. That's why the fluid tends to shrink into the circular area. This is because of the surface tension. We will discuss again this one in the next slide. Let's see first what is the dimension of the surface tension. Surface tension has the dimension of force per unit length, that is the how much force is there on the unit length, that is the surface tension, or surface energy per unit area. So this, what is the dimension or unit for the surface tension? This is, you can see, force per unit length. From here you can find out the what is the dimension or unit for the surface tension. Force is Newton, length is meter, Newton per meter, that is the force per unit length, that is the dimension, that is the unit for the surface tension, Newton per meter. Or dimension, you can say, what is dimension for the Newton? That is the MLT minus 2. You can find out, you have to do this exercise, per unit length L, that is the is MT minus 2, it becomes the dimension for the surface tension. Now again we are going to discuss this surface tension in more elaborate way. So surface tension is the property of the fluid. Because of that fluid tends to shrink into the minimum possible surface area. Let's see. When fluid is there, then around this atmospheric air is there, that is atmosphere is there. So it is having the interaction of liquid air interface. It is having the liquid air interface. It is having the liquid air interface. So you can see, if I plot, this is the fluid, that is the inside water, that is drop of water is there. So outside of this air is there, right? Atmospheric air is there. So this surface tension results from the greater attraction of the liquid molecules. You can see inside this liquid molecules are there. So this liquid molecules try to make it inside, that is the inside force is happening, and outside force is there because of the air, outside force is there. Air is trying to put out, while this inside molecules trying to pull in. So pull out is there because of the air outside, and pull in because of the liquid molecules inside. This is happening on this outer layer of this water molecule. This is happening on the outer layer of the water molecule. We are taking the example of the water molecule. So on the surface forces are there, outside forces and inside forces. That's why on the surface, because of the forces on the outside and inside, on the surface forces are there outside and inside. Because of that, surface tension is created on the surface. This is tension is created on the surface, that's why it is called the surface tension. A tension is created because of the forces pull out and pull in, and this is on the surface, outer surface. That's why this is called the surface tension property. And because this, as the inside pull in, that is the forces because of the molecules inside, that is more dominant than in case of the outside forces. That's why it is taking into the shrink, that is the, it is making the area shrinking. If the outside forces is more dominant, then in that case it is not able to shrink, it is having the flat type area. So it's depending on, it's most depending on the which force is more dominating, inside force or outside force. In general, inside force is more dominating, and that tends to the that because of that it makes the minimum possible area, and it takes the shape of the circular or nearly circular shape. So this is because of the property of the surface tension, as on the surface tension is created because of the outer and inside forces. That is the surface tension. This is called the surface tension. So how surface tension comes? Because of the forces on the surface, tension created on the surface, and because of that, depending on the inward force and outward force which is dominating, in general net effect of the, you can see here also the net effect in an inward force is more. Because of that, this surface shrinks into the minimum area, and this is called the surface tension. This is because of the surface tension property. So that is the surface tension. So next, coming to the next property, capillarity. Capillarity is the ability of the liquid to flow in a narrow space. This capillarity, this is the ability, this is the property of the fluid. Because of that, it is able to flow in a narrow space under the action of cohesion and adhesion forces or surface tension forces. In the surface tension forces, cohesion and adhesion is acting. So let's define the cohesion and adhesion also. What is cohesion? That is the, mostly we have already gone through it, hope so, in the previous in the class of 12th, hope so. Cohesion is what? That is the attraction between the similar type of molecules. That is the similar type of molecules. That means the molecule of water is there in a water or in a liquid. If liquid is water, then there is the number of water molecules will be there. So forces between the same water molecules or forces between the same molecules is treated as the cohesion. While if two other different molecules are there, that is, if the water is poured into the container that is having the glass surface, this is the glass container, and liquid is there inside. So if you see the forces on the surface of this glass, that is the glass molecule, and between the water molecule, forces will be there, and that is called the adhesion. That is the forces between the dissimilar particles, that is the adhesion. So because of this cohesion and adhesion, surface tension is created. Surface tension comes into the picture because of the cohesion and adhesion. As you seen in the previous slide, water molecules are there, and there is different molecules of water is there inside that surface, and outside air molecules are there. So on the surface of this water molecule, inside or inward forces is because of the water molecules, because of the cohesion. However, on the outer forces, it is because of the forces between the air and water molecule. So that is the adhesion. Inside cohesion force, and outside it is the adhesion force. So because of cohesion and adhesion, surface tension is created on the surface. So this surface tension is because of the cohesion and adhesion forces. If the cohesion and adhesion forces are there, surface tension comes into the picture. So when surface tension comes into the picture, then capillarity also comes. So capillarity here, main focus is on the capillary. What is capillary? Ability of the liquid to flow in a narrow space, that is called the capillary. So this can also be defined as the tendency of a liquid in a capillary tube to rise or fall as a result of the surface tension. We have seen capillary, we can hope so you have gone through the capillary tubes. In that there is the fall or rise of the liquid. So it's depending on the which force is more dominating, cohesion force is more dominating or adhesion force is more dominating, rise and fall will be there according to that. So that is the that means the flow is rising or flow is falling. That is the flow of the, that is the, in a capillary either the flow may rise, it may fall. That means that is the capillary is having the very small diameter tube. Capillary is having the small diameter tube. This is treated as a small diameter tube. So fall of the liquid or rise of the liquid, that is the, it is the flow of the liquid in a narrow space, that is the capillary. You can take the example of the within the ground, within the pores of the soil, capillary forms. That is the very small, very small, you can say gaps are there, in that fluid is rising or falling, that is the capillary. In simple words, capillary is the ability of the fluid to flow in a narrow space under the action of the surface tension or cohesion and adhesion forces, that is the capillary. Now we will move to the next property, that is the viscosity. Viscosity already defined, we have discussed little bit in the previous session. So that's viscosity is the, you can see here, viscosity is the property of the fluid. Because of that there is a different fluid layer is having a different velocity. So it can be defined as viscosity, property of fluid that offers resistance to the resistance against the movement of one layer of the fluid over the another adjacent layer of the fluid. That is the fluid, suppose this is the bottom, then this is the one layer, this is the second layer, this is the third layer, first layer, second layer, third layer, different layers of fluids are there, and this is the suppose top surface, in between different layers are there. So movement of one layer, this offer the resistance to the next layer, this layer offers the resistance to the next layer. Because of the resistance, the velocity difference created. So this property of resistance comes if the viscosity exists in the fluid. So this viscosity, it offers the resistance to the movement of the fluid layer over the another adjacent fluid layer. Layer 1 is there, over this layer 2 is there, that is the layer 2 is called the another adjacent layer, that is over to the layer 1. So viscosity, because of the presence of the viscosity, there is some resistance offered to the movement of the one layer of the fluid over the another layer. So that is the viscosity. So viscosity, it depending on the temperature, and that means viscosity of the liquid decreases with the increase of temperature, while viscosity of gases increases with the increase of temperature. You can see here viscosity, if the fluid is liquid, then the viscosity will decrease with the increase of temperature. If the fluid is gases, then viscosity increase with the increase of temperature. Why this will happen? In case of the liquid, when temperature is more there, then the liquid molecules separated each other. That means bonding becomes weak within the molecules of the liquid. They are far from each one. While in case of the gases, these molecules comes together close when the temperature is increased. When the temperature increase, then gases molecules comes close to each other, and that increases the viscosity. While in case of the liquid, molecules are far away, going to far away from each one, so it decreases the viscosity. In case of the gas, it comes together and increases the viscosity. That's the effect of the temperature on the viscosity. So viscosity, dynamic viscosity will be the kinematic viscosity. The word dynamic is used when the force is involved there. When there is no force, kinematic is there. So we can define the relation. This is the viscosity, SI unit and CGS unit. Also we can define this one. So let me define here is the one is the dynamic viscosity, kinematic. In dynamic, force comes into the picture. Kinematic, there is no force. So what is the relation between them? Mu upon rho, that is called the nu. Nu is called the, this is kinematic viscosity, while mu is called the dynamic viscosity. Mu dynamic viscosity, nu is the kinematic viscosity. Rho is the density. Rho is the density of the fluid. So this dynamic viscosity is represented by the term mu. SI unit for the dynamic viscosity is Newton second per meter square. You can find out it also from here, this relationship. This Newton second per meter square also called the Pascal second. In the CGS, dynamic viscosity is Poise is the unit. Poise is the unit in case of the, that is the CGS unit, not the SI unit. You have must gone through the SI unit and CGS unit. So in case of the SI unit, Newton second per meter square is the SI unit for the dynamic viscosity, while in case of the CGS unit, dynamic viscosity having the unit of Poise. What is the relationship between them? That is the Poise and SI unit. SI unit is what? Newton second per meter square, or also called the Pascal second. So this is Pascal second is the SI unit. This is the SI unit, while this Poise is the CGS unit. So relationship between these two units, CGS and SI for the same dynamic viscosity. 1 Poise is equal to 0.1 Pascal second. And 1 Pascal second is rated as the 1 Newton per meter square. So that's conversion is there from CGS to SI unit. If you are having the 1 Poise, that means that it is 0.1 Pascal second in SI unit. That is the dynamic viscosity. You have already seen this relationship, dynamic viscosity and kinematic viscosity. Then we can see here, if there is the, let me see it here, mu upon, this is mu upon rho, that is the nu. So mu already, this nu is having the dimension of L2 T minus 1, that is meter square per second. Meter square per second is the unit for the kinematic viscosity, and this dimension will be L2 T minus 1. So this is the relationship that you have to know between the kinematic and dynamic viscosity. You have to know about the dimensions, unit for the kinematic and dynamic viscosity. Rho is the density here. This is about the density. So next, one more property, we will see the compressibility. Compressibility, what is this? This is the measure of the relative volume change. Compressibility, that means if you compress something, then how much volume is changing. That is the relative volume change of a fluid upon the application of the forces, pressure or stress. That is, when some force is applied, then how much volume will change. That's defined the compressibility. So if application of pressure changes the volume, If volume will change, density will change. It changes the volume or density of the fluid, then the fluid is called the compressible fluid. That is, the fluid is compressible if with the application of the force, the volume or density of the fluid is changing. If the density of the fluid is changing, then that means it is having the compressible fluid. If density is not changing, it is called incompressible fluid. If you remember, in the previous session we have discussed about the ideal fluid, that is the incompressible and no viscosity. Incompressible, that means the density is not changing, density is constant, is not changing with the application of the forces. So the density will change, it is called the compressible fluid. That's about the compressibility. So we have discussed about today about the properties of the fluid. In the next session we will discuss about the pressure measurement in manometer. Thank you for this session. Thank you.